Okay, well, welcome everybody. Um, we have set up a demonstration for the TR50X tray former designed for parchment line trays. Um, by design, we've placed everybody on mute, and I believe also your cameras are also disabled, just to make sure that it's not chaos. Um, I am monitoring. My name is Ben, and I'm monitoring chat. So any questions that you're comfortable asking in front of a group setting, please feel free and enter those at any time. I will, go through those with Jay Bachman. Will be guiding this demonstration, and there he is at the top of the screen. So we have a wide view at the top of the screen, and then a focused view, which is at the lower end of your screen, and that will be moving around as Jay's wanting to, talk to the machine. If your view is not capturing the entire machine on the top of the half the screen, you may want to adjust your screen size, actually possibly even make it smaller than in full maximum, and that will actually make that work. Um, uh, Mackenzie, I see you saying hello, so the chat is working. Please, anytime, message and I'll stop the demo and have that conversation. Jay, I think we're good. So
okay. Well, good afternoon. Thank you everyone for participating. My name is Jay Bachman. I'm Vice President and General Manager for Wayne Automation. I'm very pleased to be presenting our machine to you today with our partners Innovative Fiber, who is providing the core lock trays that we are running today, with our adhesive partners, Bostik Hot Melt Adhesives, and Taylor Chemical, who is providing the cold set adhesive. This machine today, and I'll start it, just start it running while we're talking here. This machine today is forming trays at rates up to 50 trays a minute, parchment line trays from, again, Innovative Fiber, that is being set instantaneously with a hot set adhesive to create an immediate bond, as well as a cold set adhesive that will provide the long-term oven-safe, oven-proof bond needed for the baking environment. This machine is a derivation of our equipment that we have sold for many years for the tray forming environment. It's been adapted specifically for the baking environment, dealing with the challenges of the parchment line tray and the dual adhesive solution. What you see on the close-up view is you see the trays being picked from the magazine and delivered past the yellow rollers where we have our glue heads placed, both cold and hot adhesive, and then into our forming section. So I'm going to take our focus view, and you'll see me in the view here, in the main view, and I will move around our camera to give you better focus views of what we're doing. So I'm going to turn our camera here, and there you can see our forming manual coming down and providing the forming of the tray to give us a nice square-walled glued tray. Now, unique to most tray formers, or unique to our tray former, unlike most, is that our forming manual does not push the product through a static die, which could leave you with a substandard result. Our machine has a set of rotating dies, servo-controlled on the shaft that we deliver the paper across, that allow us to precisely and accurately fold the sides of the tray blank up while the forming manual drives down through prior to compressing. Now let me stop for a minute and I'll go through some more details of the machine. So I'll stop for a moment and talk you through the details of the mechanics of the machine. And then we'll get into the running operation of the machine a little more. And then we can give you a static tour of electricals and aspects like that. So you'll see me, again, moving my view around, and you'll get a better understanding of the equipment. So to the side here that I'm pointing by the HMI is the magazine for the equipment. The magazine holds about 8 feet of blank stacked behind a pressure plate. I'll move over just so we can see that in a little more detail. So here is our magazine. This magazine indexes paper forward with each successive pick. And this pressure plate walks along with the paper on the afterward belt that the paper sits on. As we go to pick the paper, come to the front side of the magazine inside the machine. And you see the paper presented to the front magazine gate. The static gates sent for the paper size and are picked by our servo linear and rotational pick system. So this mechanism both travels in a linear fashion as well as a rotation to give a good, reliable pick of the paper and present it to the rest of the machine. After we pick, we deliver it to our transport section. We have a servo linear transporter that will push the paper past the glue heads under these yellow rollers so that we can apply our adhesive precisely and accurately. With the dual adhesive that we are applying here, precision is of the utmost importance. Precision of the hot melt stripe, precision of the cold glue stripe, so that there is no squeeze out beyond the targeted areas, so that we have a good adhesive bond to allow that tray to survive in the oven. Then as we complete, we come down to the compression section, down at the discharge end of the machine. So the compression mandrel will drive down through the paper, through our servo actuated forming grounds, and into these compression mandrels, which move in and out of the machine, providing the clamping force needed to provide very good fiber penetration for the glue and a good adhesive bond transfer. When that's completed, we discharge out of the end of the machine onto our powered conveyor belt, taking the tray away up to your next activity. I'm going to start the machine back up, and I'll just move through these various functions of the machine again so that we can see and watch what is happening. Now, you see me running with the guard doors open. We've disabled some of those safety features for today for clarity of view while we're here demonstrating in our shop. Obviously, in any installed environment, that is that would not happen. I'm going to re-energize the machine and reset. Our vacuum pump turns on, our hot melt adhesive system turns on, and we can begin producing. Now here, for clarity of the demonstration, we are picking and operating at 15 trays per minute. Microsoft Teams doesn't have a frame rate that supports a very high-speed demo, so for clarity, we are running it very slowly for your viewing. We'll do a little speed demonstration a little bit later on. So here you see our pick mechanism picking and taking the blank from the magazine. Now you see that blank being delivered to our servo linear transporter. So we deliver the blank between our guide rails, and our servo transporter pusher escorts the paper in and past the glue head. As we go to deliver past the glue head, I will zoom in on that feature for you. You can see the lead edges of the tray blank traveling underneath the yellow rollers, which keep the tabs of the tray controlled and managed against the rails for accurate communication. As we come into compression, I'll take my camera out and give you a little more close view. You can see the tray transferring past glue head, now deposited with adhesive, ready for forming. In this application, we apply the hot melt adhesive first, and then we apply the cold adhesive. So that gives you a real good close-up view of each application. As we come into the forming section, you can see a tray fully delivered into the forming mandrel and being driven down into and through the servo-controlled forming rounds. Those forming rounds are doing two functions. They are folding up the inner side flap, and they are rotating the end walls up and tucking the flaps, as you can see. Then down right below the forming rounds, you can see the compression mandrel drive and set the glue. Here at this speed, we're experiencing about 300 milliseconds of glue set compression. That's enough time for the hot melt adhesive to reach its max temperature and hold the bond line so that the cold adhesive can begin its cure phase as it discharges from the machine. I'll now slide around to the end where you can see the discharge. So trays drop down out of the forming section and onto our conveyor.
Jay, stay put for a second. It was kind of pixelated at the exit.
Sure thing. I will stay right there. Hopefully that's cleared up a little bit.
Yeah. Okay. A little bit better. I think it's clear enough, though.
Now, to show you a little bit better what that cold adhesive application and hot melt adhesive application looks like, I'm going to stop the machine through an e-stop at the forming section here, so you can see what a delivered tray looks like as it comes into the forming to see the glue stripes that are applied. So I've now initiated an e-stop of the machine. And with this purpose, now I can get in nice and close and show you a tray delivered to forming section. And here you see the hot melt adhesive stripe and the cold set adhesive in board. The hot melt is there, again, purely to hold the tray formed until the cold set adhesive fully cures. And there you can see it as well on the downstream stripe. Looking across to the other side of the piece of paper, you can see the same far side. Now, to achieve the precision we need at the kind of production rates that are required for this machine, we have a Valco hot melt adhesive and Valco cold adhesive dispense system, all fired with a solenoid actuated electrically opened electrically closed gun. Those guns are fired off of the servo position of our transporter, giving us extreme accuracy and consistency, repeatability in the placement of our adhesive, so that every tray comes out formed, ready, bonded, ready for transit into your oven. I'm going to take a moment now and just give you an overall tour around the machine and show you some more details. So starting at the magazine end of the machine, and I might disappear out of the overall view, but I am down at the magazine end. And what you see underneath the magazine is our Valco Melton hot melt adhesive tank system. This is a gear pump driven system for heating the Bostik adhesive at a very low relative temperature. We keep that tank at about 275 degrees. Low adhesive temp, make the product handle extremely well and provide extreme durability in the storage of that material. Next to the hot melt adhesive pump is our cold adhesive dispense system. Also a Valco Melton system. This cold adhesive pump system is rolling cold set adhesive from a pump bucket down below that you can see here. Now, we're using a 5-gallon pail for this demonstration. That could easily be put into a 55-gallon drum of adhesive or a 500-gallon Gaylord, whatever suits your operational needs. As we walk further down the machine, the operator screen, I'll spend a moment here touching on that and showing you what that operator station looks like. The HMI is a Allen Bradley panel view 10-inch HMI. I think I've got a good view there. Ben, is that coming across reasonably clear?
Yeah, it is.
Good. The HMI shows the current set speed of the machine and then its current operating speed. In green or gray are the run modes of the machine. When all are green, the machine is ready to go into full production. When any one of these modes is grayed out, it's a non-production mode. You'll notice for the moment I turned the cold glue off, just so we don't have a alarm that goes off that warns you that the cold glue is sitting. I'll go into that in a little more detail in a moment. We have the speed status of the machine. So this is a continuously variable speed machine. You can dial a speed, whatever position or whatever rate you want, and the machine will, on the fly, dynamically accelerate or decelerate while maintaining full production. And we'll do a little more of that as we get further into the demonstration. I'm going to go around to the backside and show you a little bit of the electrical cabinet. So I'm going to disappear from the main overall view. I'm going to pop around to our main electrical cabinet. On the far side of the machine here, if I can get back far enough, prop that door open. In the main electrical cabinet, we have, we have mixed voltage of high and low voltage. Let's say, but apologize for that. We have a mixed voltage 480 volt cabinet. High voltage is to the top of the cabinet. Lower voltage control power is down to the bottom end of the cabinet. So just to the right of the electrical controls enclosure is our hot melt disconnect. It's an option available on the equipment that allows when de-energizing the main electrical enclosure that you can keep the hot melt system energized and active so you're not losing temperature in the tank, allowing you to recover and restart properly. I'll go a little closer in on the cabinet to show you some of the details. Providing the main control to the machine is a set of Allen Bradley Kinetics 5500 series servos. Next to it, controlling the discharge conveyor, is an Ethernet-enabled Allen Bradley PowerFlex 525 variable frequency drive. Coming down through the cabinet, we are now in the control section of the machine. Main PLC for the machine is a Allen Bradley Compact Logic 5069 series processor with second Ethernet-enabled port for your plant communication should you so desire. Additionally, next to it, standard in this machine and every Wayne automation machine, is a E1 remote access VPN point. This point, when enabled at your facility, allows our technician, should the need arise, to remote in and provide setup assistance, diagnostic assistance, or any other form of support where we would log into the P-station. While we cannot solve every potential issue you might occur, even when a service visit is required that requires boots on the ground, by doing pre-diagnostic work through this VPN point, we can maximize the effectiveness and timeliness of that service to get you the support you need should the situation arise. And while nobody can speak here today, if there are questions, please do enter them into the chat and Ben will relay them to me and we'll be happy to help you out. I've moved slightly to the right and I'm showing the two Valco glue controllers, one for hot, one for cold adhesive, both providing the control and accuracy for the electric gun dispense. So that's giving us lots of control over where we apply that adhesive to give you a high quality product. The machine includes, by standard, a Hoffman electrical cabinet air conditioner. So regardless of what your environment may be, cold or hot, we are assured that the servos and the PLC are adequately cooled and kept sealed from whatever your operating environment may look like. Services you bring to the machine, in addition to 480 volt power, you'll bring to us a pneumatic air supply. Shown with a manual Ross lockout tagout valve. Bring your 3/4 inch NPT line to us. Approximately 75 to 80 PSI. The machine consumes roughly 8 CFM in its fastest speed of operation. To generate the vacuum that we need to have good performance picking from the magazine, we have an integrated Becker carbon vane rotary pump generating 26 plus inches of mercury vacuum in the machine. Here's a close-up of that pump living underneath the magazine. That pump is protected by built-in filtration down at the end of the magazine. Shown here with an easily inspectable, easily serviced high-end canister filter. Now, many of our applications will require more than one size of tray. This machine is designed for a wide range of sizes, from small to large. When a changeover is required, we have a range of scaled adjustments, marked and numbered, and provided on a setup sheet. I'm highlighting a few of these scaled adjustments here. There is no adjustment that is made in the routine usage of the machine that is not scaled and numbered for repeatable, accurate changeovers. However, to complete a changeover and run a different format tray, we have quick change removable tooling. Shown here on the table is a quick change mandrel that can be exchanged in and out of the machine for different footprint sizes of tray. In addition, we have a pair of quick change compression plates, again, that squeeze the tray shut to provide the best possible glue draw. Here also on the table is a close-up of the innovative fiber core lock tray presented here. And this one was glued a little while ago, so the cold set adhesive has now begun to cure and go clear. Next to it here is a finished product tray. The quality attributes we're looking for here on this tray that we can provide consistently and accurately are very accurate square flaps, providing nice, accurate 90-degree sidewalls as this tray application requires. As we look inside the tray, we see nice folded corners so that your product in the tray has good, consistent, accurate shape, what you desire. So with this tray material, with our machine, with the Bostik and cold adhesives, we have the ability to provide a very consistent, repeatable, and accurate watertight tray that is leak-proof and meets your needs over and over again. Hopefully that was instructive. And I see that there was a question. What about trays without a 90-degree angle? That's a good question. We have designed this machine to do draft wall trays at varying angles, whatever innovative fiber can produce. So this machine here will run with a setup and changeover, a 9-degree, 11-degree, 13-degree wall tray, whatever is needed, all with just a different set of change tooling specific to that product size. Hopefully that answers your question. Again, please feel free to add more questions into the chat. Ben, call them out as you see them.
I will. Thanks, McKendry.
Okay. I'm going to resume running the machine again, and I'll just place my camera into the nice view. And you know what? Actually, I'm going to focus on the HMI. I'll show you this as we run. I'm going to show you the variable speed nature of the machine and how easy it is to change your production speed either through an HMI selection or through line controls, whatever you need. I'm going to go through my mode selection. I'm going to turn my cold adhesive product back on. Go to my operator screen, and we see a set point of 15 a minute. Our current run rate is 0, obviously. The banner at the bottom is calling for me to do a machine reset, which I'll initiate now. Now, in the overall view, you may or may not be able to perceive some of the speed differences, but I'll show you how we change speed. So now you see that the machine is at run speed, cycling at 15 a minute, which is what its set point is. If our application requires additional speed, I can simply go in and press 20. We'll see the machine accelerates up to 20 case a minute production. If I then wish to slow back down, it's as simple as re-entering a new speed. I wish to run double this speed. I simply enter it, and the machine in a couple steps will accelerate up to the set point speed. Now running here at 30 cases a minute. And hopefully that's coming across reasonably smoothly on the HMI. So continuously variable speed allows us to accommodate your production needs with minimal accumulation, whatever that would be. And then to slow back down is as simple as pressing in a number. There's no pause in the production. There's no loss of cases. We can just continue to produce, albeit at different rates. And that's through the full servo application of this machine. Now, in a real-world line control setting, I'm going to demonstrate for you, what if your line backs up? What if you don't have a need for more trays? My helper here is going to simulate a line backup. We have a downstream photo eye mounted on our conveyor for this demonstration, blocking the eye. The machine goes into a dry cycle. So the machine is now no longer producing cases, cycling at the desired rate, albeit with no products. It's allowed to stay in this position for a set amount of time, in this case, 1 minute in this demonstration. The machine will say, you have ignored me. I'm going to initiate an automatic stop. And we'll stop producing product altogether. We'll stop the motion altogether. We'll let that come to a stop here as we demonstrate that, and then show you how the machine, when the downstream line is cleared, will automatically resume full production. That's a user settable parameter. So the machine has now stopped. It is still in a production run state, however, it is not producing. Chris, if you'd allow that to clear now. The line condition is cleared. The machine enunciates a restart. and again, immediately resumes back into its automated production, producing trays at the desired set rate. So if your operation is manually transferring these trays to a depositor or next operation, or queuing them for some later batch process, or running them directly onto your depositor in some automated fashion, the machine will adapt readily and easily to whatever your current production rates and needs are. I'll initiate a cycle stop of the machine. A cycle stop finishes out with all perfectly good, usable product and brings the machine to a controlled rest, ready for a restart. Now, cold glue, as everyone may or may not have experienced as a child, I think everyone has that memory of working with an Elmer's glue bottle when they were kids, scraping off the skin off the orange cap. And that's a concern with cold adhesive because, again, if we don't have a cold adhesive bond on this tray, then the tray will invariably fail in an oven environment. So to protect the machine from that skimming over, we have several features in place. Protecting each of our cold adhesive heads. There we go. Sorry, wrong view. There we go. Protecting each of our cold adhesive heads is a actuated hip cover that, when the machine is in production, draws back. When the machine is idled or stopped, closes and protects the tip of the cold adhesive applicator from skimming over and affecting the quality of this stripe application of the gum. Further, to prevent the cold glue system from hardening and becoming unreliable, the machine has an alarm banner that will enunciate after a short amount of time. Anytime the cold glue system on the machine has been primed and activated, we are waiting on a timer to either have the machine operate and dispense cold glue, or be purged and flushed of the cold adhesive. So if your operations team at the end of the day hits stop, walks away to do their cleanup tasks, and ignores the cold glue system, the machine will alarm and enunciate, drawing attention to the fact that the cold glue system needs to be properly decommissioned if it's not going to be for the use. To facilitate that at the end of a shift, we have an automated purging routine in the HMI that, by simply exchanging the cold white adhesive for a source of fresh water, we'll run an automated 10+ minute purge to flush the cold adhesive system with water and dump it into a waiting drain bucket down below. That way, the machine will not have adhesive in the system, and it will not cure, dry, and potentially damage the system. It will leave it in a ready state to be primed for the next production operation. The hot melt system does not need that level of work. The hot melt system, when turned off at the end of the day, the hot melt adhesive will harden as expected in the line, and then when restored to an operating temperature upon a restart, will heat up and melt and be ready for dispense. I'd ask at this time, if anyone has questions, please enter them through the chat, and I'd be happy to touch on those questions and answer them, or focus on any specific areas that's unclear. One question we've had is this machine a prototype? No, it is not. Our TR50 tray former has been in service with a wide range of beverage, consumer packaged goods, and food customers for several decades. This latest iteration of the machine, adapted to work with the innovative fiber core lock trays, is simply an evolution of an already proven, fielded, trusted product.
Jay, we do have a question related to changeover. So from one format to another, what should a customers
That's a good
expect for
question.
time-wise?
With a trained operations staff that our field technicians will train during startup, we would expect changeover to be approximately 15 minutes. Is one lap around the machine touching all the changeover points. Now, some customers have asked, can it be less? Can it be more? So any tray that has the same base footprint, which would be as they show here, any tray that's the same interior length width would only require a subset of the change points, as the mandrel will remain the same regardless of the footprint size. Simply a wall height change requires a adjustment to 2 rail points as well as the magazine, so it could be much less. If the overall size footprint of the tray changes, that would require changing the mandrel and the compression plates to those quick change tools that I showed you aside, and that would represent a typical 15-minute changeover.
Okay.
Other customers, yeah. How often should you clean the glue heads? It's a great question. The hot melt system we run at very low temperatures, at the lower end of what Bostik is recommended for the adhesives, so that we minimize the potential for any discoloration or any other adverse effects on the glue. Routine glue system maintenance is required and is estimated to be done on a monthly or semi-monthly basis. The cold adhesive system must be purged at the end of every usage to operate and remain functional in the future, and thus must be primed at the beginning of each usage. We recommend on a monthly basis removing the cold glue nozzles and the actuators and giving them a thorough cleaning in warm water. Beyond that, the glue system maintenance on a routine basis is no more complex than that.
I do have a question, and it's related to generally footprint. There was a question of currently our tray blanks are stacked vertically in the magazine. To
Yes.
reduce footprint, could they be stacked horizontally? And I will follow up with that because I know the answer, but is it possible to shorten the magazine since?
Yeah. So let me touch on why is our magazine horizontal and not vertical, like maybe you've seen in some other machines. Depending on in a vertical magazine that picks off of the bottom of the magazine, the weight of the paper is continuously variable based on how many sheets of paper are left in that magazine stack. So you could have 5 sheets of paper left and have very low weight, or you could have a completely filled magazine and have a lot of paper weight. That change in weight and thus pressure against magazine gates reduces the consistency and reliability of magazine functions. At Wayne Automation, we don't feel that that is an acceptable design compromise. So our magazines are horizontal so that the pressure provided against the paper, against the magazine gates, is consistent whether it's 5 sheets of paper, 50 sheets of paper, or 500 sheets of paper. Now, regarding the length of the magazine is offered at a standard length that holds approximately 1,000 plus pieces of paper in an E-flute configuration. While this is a standard configuration, if special applications are needed, we can always have a engineering related discussion with that customer about what reduced length magazine may or may not be able to be accommodated. Hopefully that addresses the question.
Yeah, I think so.
Some other customers have asked and said, well, while this is a tray former that you've had a derivation of for many years in operation, what is your experience working with in the bakery and food industry? We have over 20 years of experience working with bake-in tray solutions, albeit different models of our machinery. So we are familiar with the environment and the unique challenges that our customers face operating in a commercial bakery type setup. So in addition to that experience, with a tried and true proven machine adapted for the innovative fiber core lock tray, we bring a very proven solution to bear. Now, there are a couple customers that responded to today saying, I'm not familiar with Wayne Automation. So I'll take just a moment and give a brief synopsis of Wayne Automation. Wayne Automation has been in business producing packaging machinery for nearly 50 years. We were started supplying the glass container manufacturing industry, providing the case and the Interpack, the protected glass bottles as they go from the glass makers to the end users. As markets have developed and changed, we have expanded further into the beverage space, consumer packaged goods, and food industries. Wayne Automation is privately held, family run, and operated. Our sole focus as a machine producer is to provide the highest quality, highest performing, most reliable equipment we can. And as evidenced by that, our very first customer from nearly 50 years ago, a specific glass plant, continues to do business with us and purchase machinery every year of our business. It is very important to us that we establish that trust and relationship with each and every one of our customers. We've gone from one customer nearly 50 years ago to over 800 discrete active customer accounts that we have machinery and support with. This industry is very unique in that many machine builders are assemblers of machines, maybe not producers. Wayne Automation believes in 100% complete vertical integration. Now, what do I mean by that? We do all of our design in-house. We do all of our machine components for the equipment in-house. We do all of our fully welded structural steel frames in-house. All of our UL rated panel builds are done in-house, as well as final assembly. After sales, we support our equipment fully from parts inventory on site, as well as with our own Wayne Automation service technicians. Wayne Automation service technicians are not contract service techs that show up with a manual and maybe futz around to try and find an answer. They are long-term employees that have proven themselves in our shop environment, building our equipment, and have developed the requisite skills, both technically and from a customer side, to give you the support, training, and downstream operations help that you need to be successful, not for 1, 2, or 3 years, but for many decades to come. Wayne Automation is lucky to say that we have many, many, many assets that are in the 2 to 3 decades of current operational status. We design machines that, when maintained and operated properly, can run for 30 plus years without any concern. Ben, you had another question?
Yeah, I do. Related to the magazine with the tray blanks vertically stacked, could they be can they be continuously loaded, that magazine, as the machine is in operation, or should the operator pause the machine to reload?
It's a good question. So the nature of our magazine is, and I'll do a little demonstration, that this pressure plate walks forward with the paper on the Ashworth belt. So to reload, a new stack of paper can be placed in here, pressure plate brought up tight against it, and running can continue. The only situation that needs to be monitored from an operational standpoint is if you were to allow the paper at the front of the magazine to fall back. So if you take the pressure plate, like I'm going to show here, and just let it fall back and leave it like that, the machine will work to overcome that lack of boost, but could result in a potential mistake. So when loading, when adding more paper, simply bring the pressure plate back behind the last sheet of paper, pull it reasonably close to the rest of the paper stack, and the machine will continue to boost this pressure plate forward with each individual cycle that it picks. That pressure plate is indexed forward, and the paper sits on these 2 Ashworth driven belts that are indexed forward incrementally with each pick.
Okay. And any other details beyond, our answer, our short answer we're giving here, we're happy to take, I'll provide our email addresses and phone numbers, and we can get on a call together and go through those details.
Let me take another moment and give a little better summation of the functions within our HMI. Because if you cannot interact properly properly with the best running machine, then it becomes a challenge for your operation. So I'm going to walk through screens. So I showed you the operator screen, which should be shown most of the time that you're running. Showing again, current cycle rate, speed set point, current resettable case counter, and total machine cycle count. And then the summary status of the functions of the machine. Now, if we want to change those functions, we have a screen that provides more detail. The machine has a number of different functions where you can go from run to jog mode. It can be used after a maintenance activity to verify things have been put back together correctly, or after a new setup to validate that adjustments have been made correctly, whatever is needed there. We can put the machine in a dry or normal mode. Dry mode obviously does not take paper, but moves the functions of the machine. Again, could be very useful after a maintenance activity to validate proper reassembly or after an initial brand new setup. We can disable or enable separately the hot melt and cold adhesives. That would only be a usable function, again, in a maintenance action. If you are trying to run the machine without both adhesives activated, the machine will not permit you to run production. And we also have a remote local function where if you so desire in your operation, to control a remote line remotely from a plant supervisory PLC, take data back and forth from a SCADA system, we have that ability as well. In the glue pattern, we have extreme control over our products. We're looking here at the hot melt screen, and I'm going to enter a password. And we have 5 corner flap, 1/10 of an inch positional accuracy in the length and placement of those glue stripes, allowing us to make tailored adjustments independent of each side of the tray as required to give you the optimum product. Likewise, after servicing the glue system, we can independently purge the hot and cold, the left and right guns as needed for whatever purpose you might have. And then also go to the cold glue system, which again has its own 1/10 of a decimal point accuracy position for each flap, left side and right side. So we have 100% complete control over where we apply both the hot and cold adhesives on each corner, each flap of the tray, allowing us to get an optimal bond line. We have a machine overview screen that shows the safety status of the machine. Now here with our guard doors jumpered out, they're not enunciating, but it shows the current status of interlock of any e-stops or safety doors that may or may not be breached, rendering the system safe. The machine is produced standard from a safety standpoint as a Category 2 PLC rated machine. For customers who have higher required safety requirements, the machine can be upgraded to a Category 3 performance level D machine optionally as needed. Now, we've been talking about the machine, but I guess everyone's most interested in what's a bond line of the tray look like. I'm going to grab a couple trays here. I'll come stand in front of it. And let's do this right here by the magazine so I can put one down. So we're going to look here at the end of this tray. We see good square flaps. And let's look at the bond line. That's a pretty tight joint. So what we see here is substantial fiber tear in the joint. This was a tray we ran a couple minutes ago. As I try to peel that away and expose more, we get fiber tear on both sides. There we've gotten fiber tear, which disassembled the entire tray. So what you're seeing in this is a combination of the hot and cold adhesives providing a very strong bond line to the tray. Now, through our testing, what happens when you bake this tray is that the hot melt adhesive will soften and lose its grip on the paper. However, the cold white adhesive has cured and will provide an oven-proof bond line that will survive oven times and temperatures needed so that your product can come out looking proper, perfect every time. Now, in our testing, what we have seen is that a fully cured cold adhesive bond line happens in 60 seconds or less, depending upon the stripe size we put down. As I showed you earlier with the trays that we did not glue, our adhesive bond line, we're putting down about a 11 thou diameter stripe of white cold adhesive, as well as hot melt adhesive to the length of the flap, in this case, about 2 inches. So the subject tray I was showing you, when we talk about total adhesive consumption, in this tray, which is a 3-inch wall tray, we are consuming hot melt adhesive about 1/4 of a cubic inch of adhesive. So a very small amount of hot melt is holding the case together, and an equally small amount of cold adhesive. So your usage is very low, despite having an exceptionally strong bond line that is oven safe. Are there any other questions that are coming across chat, Ben, that I can answer?
No other questions that I'm seeing. Again, certainly, please send them this way through the chat, and then we'll be providing our contact information. If you want to set up a call, we could have offline.
And as we look at these bond lines again, the Innovative Fiber Core Lock tray, as we fold the flap, folds over, creates a nice pleat corner in the inside of the tray, providing what you see is a very tight, crisp joint, straight walls, very good corner bond line and score. So you get a very high quality, consistent product, consistent to, or even better than in a aluminum or metal pan. As Ben has said, if there are any questions that come after this, we are happy to field them. We've recorded today's event, and we will be making that available to all participants. And if there are anyone else within your organizations that were not able to participate today, we'd be happy to share that with them and show them this video. We look forward to the chance to have a more in-depth discussion with you about your specific applications and how our equipment, Wayne Automation, how the Innovative Fiber tray, how the Bostik adhesives, and how the Taylor Chemical adhesives all come together as a complete package to provide you a good, reliable, high-performing solution for your application. I want to thank you for your time today, and have a great day.
Thank you.
And if you'll go ahead and end the meeting for all, please.